Hello everyone, and welcome to the third video in our Class 10 time series of lecture videos in this introduction on stereochemistry. We ended the second video learning how to assign an absolute stereocenter, either R or S, and we learned that to do that, you would have to assign priorities to the four different groups on the given stereocenter atom, and then place the lowest priority group, group 4, back behind the plane of the page, and then connect groups 1 to 2 to 3, and if you go clockwise, you're R. If you go counterclockwise, you're an S stereocenter. So how do you assign priorities? That's the next question. So in answer to that, for the time being, rule 1, the atom with the highest atomic number is the highest priority. It gets priority number 1. The second highest gets priority number 2, and so on. So, for example, we've got our nice example of 1 bromo, 1 chloroethane. And so we've assigned priorities. One first priority is the bromine because it has the highest atomic number. Second comes the chlorine because it has the second highest atomic number. Third comes carbon, so this methyl group. And then fourth is hydrogen. Hydrogen is our lowest atomic number of 1. And so if we place the hydrogen behind the plane of the page and connect 1 to 2 to 3, we see, oh, this is a R stereocenter. For isotopes, so say you have, deuterium and a hydrogen. Well, the one with the higher mass gets the slightly higher priority. And here's a trick, which we'll review at the end of this lecture video about bond line structures. We know that in our bond line structure, the wedge bond means your group is coming out of the plane of the page towards you, and the dashed bond means the group is going back behind the plane of the page. It's almost as though we've put our lowest priority group, our priority number 4 group, which is hydrogen in this case, already back behind the plane of the page. We can still see it because it's got the dash bond, but this trick works well enough. Now we assign the other priorities. Well, oxygen is first, the carbon of the methyl group is second, and then deuterium is third. It's slightly higher in priority than hydrogen because it has a higher mass as an isotope. So if we connect 1 to 2 to 3, which way are we going? We're going clockwise. So that means this is an R stereocenter. So you can pretty easily assign stereocenters directly from the bond line diagrams. You don't have to go through this trick of picking the molecule up and treating the stereocenter like a tack and placing the lowest priority substituent through the plane like a sharp needle. You can still see it. You know it's back behind the plane of the page, and this technique works well enough to go ahead and use when you assign stereocenters on a bond line diagram. Next rule. What if you have two groups that have the same atom directly attached to the stereocenter, but they're different groups? Well, you have to go to something called the first point of difference. So in this case, we have R2-butanol. The question is, how do we assign that stereocenter? Because we know that our hydrogen is the lowest priority. It's already in the back with the dashed bond. Our first priority is oxygen, but now we've got an ethyl group and a methyl group. Those are both carbon. So why does the ethyl group get a higher priority than the methyl group? Well, what is on the second group? It's a carbon that's bonded to the stereocenter, obviously, but what else is it bonded to? 2 hydrogens and another carbon. Over here on the methyl group, we're bonded to the stereocenter, yes, and we're a carbon, but what else is it bonded to? 3 hydrogens. So the one carbon that this carbon is additionally bonded to, as well as the 2 hydrogens, that carbon is a higher priority than the hydrogens to which this carbon is bonded to. So 1 carbon and 2 hydrogens beat 3 hydrogens in this very strange organic chemistry poker, because this carbon has a higher atomic number than that 3rd hydrogen that's coming off of our methyl group. So we have to assign the ethyl group the higher priority. Let's try this again. These are 4 different groups coming off of this atom. Hydrogen's our lowest priority substituent. It's got the dash bond. It's back behind the plane of the page. Our bromine gets the first priority. These are carbon atoms bonded to the stereocenter. Well, what else are they bonded to? This carbon atom is bonded to 2 hydrogens and a carbon. This carbon atom is bonded to 2 carbons and 1 hydrogen. So it gets the higher priority because it's got that additional carbon that outweighs the hydrogen on this arm. So if we now assign this as the 2nd priority and this ethyl group as the 3rd priority, and we connect 1 to 2 to 3, we're going in a counterclockwise motion, so that stereocenter must be an S stereocenter. So we've got to remember it's the first point of difference. So it's that first point we come to a difference where we assign the priority. So even though this arm possesses a chlorine, which is a very high atomic number, we come to the first point of difference sooner than getting out to counting that chlorine in terms of assigning priority for this arm. So how do we do this? Hydrogen's our lowest priority. It's in the back already. Thankfully, chlorine's our first priority substituent. Then both of these groups have carbons. Well, what is this carbon bonded to? Directly, 2 hydrogens and a carbon. We don't look further than that. Even though this carbon is bonded to 2 hydrogens and a chlorine, we don't look further than what this is bonded to if that's where our first point of difference occurs. So, like I said, on this arm, 2 hydrogens and a carbon. On this arm, on the left, this carbon is bonded to, 1 hydrogen and 2 carbons. So we don't care what are bonded to those 2 carbons. We don't care what's bonded to that 1 carbon. This has already made the difference to assign this arm the higher priority. So again, if we connect 1 to 2 to 3, we're going in a counterclockwise motion. The stereocenter in this molecule is an S stereocenter. So, as I said, I'll take you through the trick and maybe show you a little twist with our simple trick. Since it's usually hydrogen in a dashed wedge structure that gets the lowest priority, you can go ahead and assign different priorities. This is R2-butanol, and so how did we reach that assignment? Well, our oxygen is first priority. This particular arm, this ethyl group, is 2nd priority because of the first point of difference. Our methyl group is 3rd priority. We're going in a clockwise motion, so that's an R group. Now, so here's a model of that where you can see the alcohols coming up, the methyl groups going down to the left in the plane, the ethyl groups going down to the right in the plane, the hydrogens going back. Now, just because I flipped this thing over doesn't mean its stereocenter changed, right? So here's another simple trick. You can still assign priorities even in the bond line diagram where your lowest priority group is pointing up, and then connect them. You just have to remember to reverse whichever directionality it's telling you. So we connect 1 to 2 to 3. It looks like S, but since our lowest priority group, hydrogen, is sticking up, we have to remember, it's really R. So there's the other trick. So let's look at this one. So if we go ahead and assign priorities, oxygen 1, ethyl group 2, methyl group 3, it looks like R, but the hydrogen is coming up at us, so we know we have to reverse it, so it's S. In this one, now we assign priorities and follow through with the correct directionality because our lowest priority group is pointing back. It's got the dash bond to the hydrogen. So first priority, second priority, third priority, and we're going counterclockwise. Now our lowest priority is back, so we know that this is truly S. And yeah, this molecule is basically this one. It's just been flipped over. So hopefully you've come to a better sense of how to assign stereocenters based on the first point of difference. We'll look at a little deeper way of assigning first points of difference with multiple bonds, and then explore wonderful things called Fisher projections in the next class time series of videos.